Hello friends, this video on polynomials part 11 is brought to you by examfear.com. No more fear from exam. Let's talk about factor theorem. Factor theorem says that if px is a polynomial of degree n where n is greater than 1 and a is any real number, then x minus a is factor of px if pa is equal to 0. This is something which we have seen in the remainder theorem as well. And if PA is equal to 0, then x minus a is a factor. So both way it is true. See, when you talk about factor, for example, I talked about 15. 15 is nothing but 3 into 5. 3 and 5 are factors, so 15. Similarly, if you talk about 16 is nothing but 2 into 2 into 2 into 2. 2, 4, 8, 16. 2 is the factor of 16. 4 is the factor of 16. 8 is the factor of 16. Right? If you talk about 18. 18 is nothing 3 into 2 into 6 into 3. Yeah. These are the factors of 18. Right? So for polynomial, if x minus a is a factor of px, then pa has to be equal to 0. The remainder is 0. I think we discussed this. And other way around also, if pa is equal to 0, then x minus a is factor of px. This is called factor theorem. Okay, so let's take some numerical on this. Find the value of k if x minus 1 is factor of this. See, if x minus 1 is factor of this particular, let's suppose this is px for this polynomial, then p of 1 will be 0. Right, since x minus 1 is factor of px, factor theorem. So let's put the value of p1. 4 x cube is 1 cube plus 3 x square is 1 square minus 4 into 1 plus k is equal to 0. So you solve this. This becomes 4 plus 3 minus 4 plus k is equal to 0. Okay, and this gets cancelled, or k is equal to minus 3. So for k is equal to minus 3, x minus 1 is factor of this particular polynomial. Pretty easy. Please note, I am repeating once again, if there is a polynomial px, if x minus a, please note a minus here, is factor of px, then pa is equal to 0. Okay, there's a minus here. So if p is a minus here, x minus 1, so I told p1 has to be equal to 0. So I just told you that you can factorize. For example, you can say 6 as 3 into 2. Right? Similarly, x plus 2 whole square you can say as x plus 2 into x plus 2. Right? So okay, so we'll see how can we split a polynomial into various smaller polynomials, or we can write a polynomial px as some qx into rx. Okay, splitting method is something we already know. So we have already studied this in the previous class. So if we have something of the form x square plus lx plus m, I can actually factorize this. We can split this lx and I can write this as x plus a into x plus b form. I can write that, where I'll split lx, where my lx will be ax plus bx and m will be equal to ab. I'll show you how. This is nothing but x square plus x into a plus b plus ab. So if you compare these two terms, L is a plus b and m is ab. This is something we have seen this. Okay, for example, if I have to split x square minus 4x plus 4, so I'll split this into x square minus 2x minus 2x plus 4, right? 2 into 2 is 4 and 2 plus 2 is minus 2 into minus 2 is plus 4, and minus 2 plus minus 2 is this one. This becomes x into x minus 2 minus 2 into x minus 2. So this becomes x minus 2 into x minus 2. Right? This kind of things we have done in the previous class. We call this factorize by splitting the middle term. This is the middle term. Okay. So we have done this kind of questions in the previous class, where typically this the coefficient of x used to be 1. Let's try factorizing this kind of equation, ax square plus bx plus c, using by splitting the middle terms. So here also we have to split. So this we can split in the form of px plus q into rx plus s form, right? Because this is degree 2, this is degree 1, this is degree 1. So x into x will give you x square. So if you actually solve it, you end up getting prx square plus you get ps plus qrx plus you get qs. So we compare this term is this, and c this term, and a is nothing but pr. Now you see here also b is nothing but sum of two numbers whose product is c, ac. B is nothing but, if you see, ps plus qr, right? And if you see, c is nothing but qs. If you multiply these two numbers, so you get what? PR into QS. Let me write PR into QS. And if you add these number, PS and QR, right? So here B is nothing but addition and AC is nothing but product. Same thing, it's all same. If you are confused with this, you can just ignore this part as well. I'm just trying to give you a better view of factors theorem. The point I'm trying to drive here is you always have to split this term in such a way that the product of these two terms is equal to product of these two. So for example, ax square plus bx plus c. This I will write as ax square plus b1x plus b2x plus c. Okay, so b is nothing but b1 plus b2, where ac is nothing but b1 into b2. Same thing here. You see here, b I have written into these two terms, where AC is nothing but multiply these two terms. Okay, alright. So that is factorizing by splitting methods. Okay, and we can take with these examples for this as well. For example, let's take this 6x square plus 5x minus 6. So here we have to split 5x in such a way that the product of this terms is 6 into 6 is what? 6 in minus 6 into 6 is 36. So what I'll do is I'll break 5 into 9x and minus 4x, right? Plus 9x minus 4x. So plus 9 into minus 4 is equal to minus 36. Please take care of convention signs. Plus 9 minus 4 minus 36, and this is what we are looking for. So what will I do is I'll complete this. So I'll convert this 5x into plus 9x minus 4x. So now what you get here, this part 3x common, 3x plus 2x plus 3 minus 2 common, 2x plus 3. So what you get is 2x plus 3 into 3x minus 2. Okay. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attend free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.